Welcome to Study Loop.
Hi, in the given problem here, this is the straight current carrying conductor below which there is a metal bar. Put like this, perpendicular to the length of this current carrying conductor. The current carried by this conductor is given as I. The upper end of this steel bar is at a distance d from the wire. Length of this metal bar is given as L, and it is moving towards right with the velocity v. Then there is a small segment of this metal bar taken at a distance r from the current carrying conductor. The width of this small element is dr. So magnetic field at a distance r from the straight current carrying conductor is given as, using Biot and Savart's law, that is given as mu naught by 2 pi into I by R. So within this magnetic field, when this small segment having the width dr moves towards right with the velocity v, then motional EMF induced across the width of the small element will be given by, let it be dE, the motional EMF, and that is given as B into V into dr, width of that small element. So it becomes mu naught by 2 pi into I by R into V into dr. So the net EMF induced across this metal bar will be given by integrating both the sides. So that net EMF induced will be given as integration of this mu naught by 2 pi I by R V dr, having the limits from D to D plus L, taking the constants out, which include mu naught by 2 pi into I into V, leaving behind the integration of 1 by R with respect to dr, having the limits from D to D plus L. So this integration comes out to be mu naught by 2 pi I V, that is natural logarithm of R over the limits from D to D plus L. Then putting these limits, this is mu naught by 2 pi I V, natural logarithm of, in place of R, first of all, this is D plus L minus natural logarithm of lower limit, which is just D. So finally, this EMF induced here comes out to be mu naught by 2 pi I V natural logarithm of, using the rules for logarithm, that is D plus L divided by D. Now, and this is the answer for the first part of the problem. Now, in the second part of the problem, we have to find which end of this metal bar will be at a high potential. So, to find it out, using this figure, due to the current carried by this conductor, the magnetic field here in this region in which the metallic bar is moving, that will be into the plane of paper. Here, this magnetic field is perpendicular to the plane of paper and directed into it, into the plane of page, using right hand thumb rule. Now, when this rod is moving towards right, so using Fleming's right hand rule, the direction of current induced in the metal bar will be from B end to A end. Hence, we can say end A is at a high potential. Now, in the third part of the problem, if this bar, metal bar, is replaced by a loop of width W, then as the loop is moving parallel to the wire and in this parallel region, everywhere the magnetic field remains same. So the magnetic flux linked through the loop will remain same. Then the magnetic flux linked through the loop will remain same everywhere at all the points parallel to the wire. So d phi by dt means time rate of change of flux will be 0. So the EMF and hence the current induced will be 0 in third part of the problem. Thank you.